Hello everyone, the September SAT exams are around the corners. We're only 15 days away from the SAT exam in September. Hopefully you guys are preparing very hard. And to support your preparation, I've decided to do a countdown series of videos where every day I'll take one topic according to the SAT syllabus. I've actually just finished recording the day 15, which is the first video of this series. And I talked about linear equations. Now, the way our videos will be structured is I will start with some theory, but I won't finish the theory first before moving into questions. I tried to break them down into smaller parts, and after every small part, I will give you some questions to solve, and I will solve them with you. Feel free to pause them, and so you can practice on your own. And I hope you enjoy these video series. If you have any recommendations and comments, please do mention them below. Otherwise, let's jump into the topic. As I said, we're going to talk about linear equations today. This is day 15, so we're just getting started here. I think linear equations is a good topic to start. I'm not going to way too back where we're talking about fractions and stuff. So since this is supposed to be a review session, I'm going to try to do as little detail as I can while trying to explain the topic in case somebody actually didn't understand it. Now, what are linear equations? Before actually we talk about linear equations, we know, since if you're planning to do your SATs in the September, I hope you know that there is linear equation, quadratic equation. Usually that's enough for the SAT, but then there's cubic equation, etc., etc. But a linear equation and quadratic equation have a very important difference, and the difference is one of them. In linear equation, the change is linear, meaning it's a straight line. Now that straight line can be like horizontal. That straight line can be upwards. That straight line can also be downwards. We're going to take a look at that in a second because they all mean different things. But it's a straight line nonetheless. But in quadratic equation, so this is a linear equation. In quadratic equation, the change is not linear anymore. So we can have a upwards parabola, we can have downwards parabola, etc. It's moving in a different pattern than a linear. That's why we're not calling it a linear equation. All right. So let's take a look into. Actually, I'm going to bring a Desmos very soon. So the very fundamental equation that we learn when we're discussing the topic of linear equation is y equal to mx plus b. Now, one thing I also want to mention is that the reason it is, the difference between linear and quadratic equation is actually determined by the power of x. Now, if you have a linear equation, the power of x, there's nothing here, which means it's 1, right? Because we don't really write 1. But when you have a quadratic equation, the power is 2. So that's how you know if your equation is a linear equation or a quadratic equation. I know it may sound very simple for some of you, but if that's the case, good. I hope it is. So y equal to mx plus b. Now, usually students ask me what m is, what b is, and even for myself, I try not to remember what they are, because usually, in textbooks or teachers would mention b is a y-intercept. And I've noticed a lot of students actually, they say the sentence, they say b is the y-intercept, but they don't really understand what that means. So to explain that a little better, I'm going to bring Desmos here, and we're going to explore. This is how I like to learn myself, and I feel like people can find that useful sometimes. Now, I don't know what mx plus b is. I don't know what m is. Y and x, I can tell they might be coordinates, but I don't really know what m and b is. So why don't we start with the very basic version of an equation? Okay, for example, y equals to 5 or 6. Accidentally pressed 6, but that's fine. Now, y equal to 6, it seems like it's a horizontal line. Now, is that a linear equation? Sure, it is. How do we know? Because it's a straight line. Now, by looking at our graph here, our equation here, we said y equal to 6. So m somehow disappeared. well, actually x somehow disappeared. Now the reason x disappeared is x is 0 in this case. M times 0, right? So m times 0 plus 6. So this is what we have right now. This is our equations. I'm just going to call this y1. In fact, we can actually go even more simple. We can start with y equal to 0. Now y equal to 0 is the horizontal line, it's the x line. It's exactly on top of it, as you can see from the graph. And then, as I start changing it, I'm going to add another one instead of changing it. As I start changing it, this graph starts to shift, right? So y2, let's say m times 0 plus 1. So it starts shifting upwards. So from there, I can sort of understand what B is. So B is, okay, it is a point where we are cutting the x line. You can see that from the graph. Sorry, we're cutting the y line. And as we shift it, this goes up and down, right? If it's negative, it's below the 0, 0 coordinates or below x line. If it's positive, it goes upwards. Okay, so that's our B. Now, what is M? M, so far, the equations that we've looked at, there is no M, or how do we know it? Because there is no indication of x, because M was 0. Now, so that means, by the way, M is called slope. I hope you know that by now. M is called slope. In fact, let me write it here. M is called slope. Okay, so we just noticed whenever slope is 0, we get a horizontal line. Okay, so let's take a look at a different case. Y equal to x. Okay, let's start with that actually. Y equal to x. Now, y equal to x, as you see, let me turn these ones off. Y equal to x is, again, a straight line because it's still a linear equation. Why? Because the power of x is still 1. It goes through the origin. It's a very specific a linear equation where y equal to x, meaning for every point, if I click on it, you see the y and x coordinates are the same. Every point on this line is always at the same distance from x and y. So y equal to x. Now, if we look at our equation, y equal to mx plus b, you will see that we don't seem to have a b here. So b is 0, but m is 1, right? So if I come here, y, I'm going to call it y3, 1 times x plus 0. This is where I am right now. 1 times x plus 0. So 1 times x is just x, and 0 is nothing. So y3 is equal to x. This is what I have. Okay, let's take it a step further. Okay, let's add something. Okay, I added x plus 2. Now I have basically everything, almost everything from, well, actually I do have everything. It's just m is 1. Everything from this slope equation, which is y equal to mx plus b. So my m is 1 and my b is 2. So what happened? This graph, basically, if I actually put this one here, it's the same graph as y equal to x. Well, it's the same graph that has been shifted 2 points upwards, right? So if I change it to, can I do that? You see, it's the same graph. If a becomes 0, it's the same graph. And then as I change it, it just shows, so because, you know, y equal to mx plus b, b just shows the amount of transformation you're doing across the y line. So we can see that by sliding it positive, negative, we can change the location of this graph, which is y equal to x plus a. Okay, good. So we have a positive slope, which is 1, and we have positive intercept right now, y-intercept to be more specific. Okay, that's fine. Now let's take a look. I'm going to turn this one off. Actually, I'll keep that one. So remember at the beginning I mentioned that the linear equations can have their straight line, but they can be upwards, downwards, or horizontal. Okay, let me move this one here so we don't. Let's see in what cases they are. We kind of saw when it's horizontal. Okay, actually we can now probably say that when m is equal to 0, meaning the slope is 0, it's a horizontal line. How do we know? Again, y equal to, not y equal to x because they're not, y equal to a constant. So these two, let me turn this one off. These two have a slope of 0. Okay, now we already have y equal to x plus a. As you can see, it's traveling upwards, right? It's traveling upwards. Now, you might say, I've actually heard people saying that, but it is coming down. We always look from negative side to positive side. When we're looking at graphs, we look from negative infinity to positive infinity. So it's an upward projection, okay? It's an upward projection, but so this is when m is positive. When m is greater than 0, we have an upward projection. Okay, now I'm going to change, let me keep that one actually, y equal to negative x minus, actually let's keep that, plus 5. Okay, again, we have an intercept, which is 5. Y-intercept is 5. But this time, x has a negative coefficient. Okay, now what that is actually is just negative 1, because we don't write 1. That's what we're looking at right now. So as you can see, let me turn this one off, and these two. Now we have a line with a negative slope, so it goes downwards. So we can conclude that m is less than 0. So if we're going downwards, we have negative slope, positive slope, when m is greater than 0, negative slope, and this one no slope, or zero slope would probably be a better mathematical term. All right, this would be a great time to actually find out how we can find the slope. Now, from these equations, we can kind of see the slopes because, again, slope in an equation, so y equal to mx plus b. Slope is just the coefficient of x. So whatever number that's standing in front of the equation, x, that will be our slope. But in the exam, you won't always, probably most of the time, have the equation. So usually you have to come up with the equation, but they have to give you something, obviously. Let's see what we need and how we can potentially find the equation of a line. Okay, now there's a few ways to do it. In fact, alongside this y equal to mx plus b formula, I want to write another formula, which is called slope-intercept form. y2, actually, y minus y1 equal to m times x minus x1. Now we're going to come back to that soon. But first thing we need is how to find the slope. Slope has an equation, okay, which is m y2 minus y1 x2 minus x1. Sometimes in some books, some videos, you can see delta y, delta x. Now what that means is just rise over run. So what does rise over run mean? Actually, maybe I can explain that better in the graph. So let's look at this graph. In fact, I'm going to turn this one on because that would be simpler. Let me see if I can zoom into that a little. All right, let's say I am taking this point, 2 point. Okay, in fact, let me do that. Okay, I'm going to give it a label so we can see it. Call call it A. Okay, now I want to find out the slope of this line. Okay, I know it's 1 because we see that y is equal to x, right? But let's actually confirm that. Now, I'm going to try to apply this formula to this equation. Okay, so A is at 2, 2. Okay, which means the x coordinate is 2 and y coordinate is 2. Okay, so I can write m equal to, so y coordinate is 2 and x coordinate is 2. Okay, now what about y1 and x1? Now every time we're looking for a slope, we always need 2 points. Now you may say, how come you only picked 1 point? Well, the reason for that is this equation actually passes through the origin, so 0, 0 is kind of given. But to make it a bit more fun, I could take another point. I'm going to call this one B. Okay. And work with these. So, again, the points of the x and y coordinate of B is 1 and 1. So, I'm left with 2 minus 1 is 1, divided by 1. I'm left with 1. So, my slope is 1. Okay, so what did we learn from this? We learned every time we're looking for a slope, assuming we don't see the equation, we need 2 points. We need 2 points from the graph so we can write our formula, y2 minus y1, x2 minus x1. Now earlier I mentioned rise over run, if that confused people for some reason. Let me see if I can show, yeah, I can show that. I'll just move it here. So what do we mean by rise over run is, let me see if I can, all right, I just pasted the graph here. So let's look at what rise over run is in case somebody is confused. So rise is basically how much it moves in the y coordinate. So I don't know if I'll be able to, there it is. This is our rise, okay. And run is how much distance we have covered in, let's pick green. How much distance we've covered in x coordinate. Okay, so for A and B, I need to look at, this part, basically, okay? How much x changed from 2 to 1? It changed 1 coordinate, right? And from B here, how much y changed? Again, also 1. So what we did m equal to 1 over 1 equals to 1. Okay, that's how we just found our slope. Again, it doesn't matter what type of, is it downwards line, upwards line, doesn't matter. We can always use this formula, y2 minus y1, again, ym equal to y2 minus y1 and x2 minus x1. Now, I've seen sometimes actually students get confused with how to pick y2 and y1. It really doesn't matter. Here is a quick demonstration of why it doesn't matter, as long as you don't, as long as you use them in the same sequence. Here's what I mean. Let's say our A point is 2 and 2, yes, and our B point is 1 and 1. Okay, same as this graph above. Now in this graph, let's say I call this one y2, x2, and this one y1, x1. Okay, so m is going to be 2 minus 1 and 2 minus 1. Okay, so the answer is 1. Okay, and now let's switch it. Let's say, let me change this marker actually. Let's say this is y1, x1, and this is this is x1, y1. Oh, I did the same mistake on the other one. x2, y2. These needs to be reversed. I'll just put that here. You get the idea. Okay, so now let's call this one M1. M2 is going to be, now I'm reversing other way around. So 1 minus 2 and 1 minus 2. So I'm left with negative 1 over negative 1, which is, again, 1. So, as you can see, it doesn't matter as long as you don't mismatch them, like pick x1 from one and pick y1 from different one. As long as you don't do that, you should be fine. Again, why? Because it just shows how the change in y divided by change on x. So it can't. So it doesn't matter. It doesn't matter which one you pick as your x1 or y1 or x2, y2. Okay. All right, we talked about what linear equations are, what is a slope, and what is an intercept. So let's try to solve some problems before we move on, and that way you just get to practice what you just learned. Okay, I used the ChatGPT actually to generate me 5 questions about this, and then let's see if we can go through them. So, first question, let's take a look. Identify the slope and y-intercept of y equal to 3x plus 2. I know it may look a bit too easy for some of you. Hopefully that's the case. But let me try this. Okay. So we have y equal to 3x. This is a very good exercise for people who are very new to the topic. So we have y equal to 3x plus 2. We could also graph it, but we'll leave that out for now. We talked about the slope again, y equal to mx plus b. M is the slope, and b is the y-intercept. Okay, so with that logic, the slope is going to be 3. So m is going to be 3, and y-intercept is going to be 2. Easy, but useful. 2. For y equal to negative 2x plus 5, what is the slope? Is the line increasing or decreasing? Now, y equal to negative 2x plus 5. First of all, what is the slope? The slope is, again, is the coefficient of x in a linear equation, assuming the coefficient of y is 1. So, in here, m is going to be equal to negative 2 because that's the coefficient of x. Is the line increasing or decreasing? Now, if you remember, we talked about what increasing and decreasing mean. If m is positive, we said the line is increasing like that. If this is m greater than 0. If line is downwards, well, the line is downwards when m is less than 0, and we have a horizontal line when m is equal to 0. So with that logic, we have a negative slope here, so it will be an increasing equation or increasing function, linear function. Third one, which of the following has a slope of 0? The first one is y equal to 5. Now y equal to 5, we don't see any x here. That means m was 0. Right, we did a very similar example to that. So m was 0. Actually, let me put it this way. Y equal to mx plus b. So if we don't see any x, that means somehow it became 0. And the only way it can become 0 is when m is 0. So in the first one, the slope is 0. Second one, we have x equal to 5. Now, x equal to 5, it means y was 0, so we can actually draw that here. Let me try that. X is equal to 5. X equal to 5, if I zoom out a bit. So x equal to 5 is a vertical line. Now, we didn't really talk about this one, but when y is 0, meaning we have a line like this one, a vertical line, the slope is undefined. There is no slope. Okay. Last one, C, y equal to 2x plus 5. Again, is the slope 0? No, it's not 0, because again, 2x plus 5, the slope is the coefficient of x, which is 2 here. So no, it's not 0. Question 4, what is the x-intercept of the line y equal to 1 over 2x minus 3? Okay, now we're getting a bit more interesting question here. So y equal to 1 over 2x minus 3. Now, y-intercept means, I know it's asking for x-intercept, but I just want to go over them because we talked about y-intercept. Y-intercept is where we're cutting the y line, okay? If we're cutting the y line, imagine you have a graph, something like this, and this is the y-intercept, this is x-intercept, right? So at y-intercept, the value of x is 0. So whatever coordinate that y has, we don't know, let's say 5, the x is 0. In x-intercept, y is 0, x is something. Right? So to find out what's the x-intercept, all we have to do is plug in 0 for y. So 0 is equal to 1 over 2x minus 3. Move numbers in one side and variables on the other. So 3 is going to be equal to 1 over 2x. One more time, multiply both sides by 2. 6 equal to x. And there you go. That's our x-intercept. Now, we can test it out on Desmos. Let's say y equal to 1 over 2 x minus 3, and let's see where it's cutting the x, and I don't know if you can see it from there. You go. It's cutting the x line at 6, so we're good. Now, so far we have talked about, let me go back to the black marker here. So we've talked about y equal to mx plus b, which is a formula for linear equation. And then we talked about we talked about the slope formula, m equal to delta y, change in y, divided by delta x, change in x. Okay, now why did we, if you remember a few minutes ago, we said why do we need to find m? So we can go ahead and potentially find what the equation of a line is. Usually that's our goal. Usually we're given some points or some points are missing and we're trying to find the equation so we can do some stuff with that equation. Now, let's take a look at this case again. Let me bring the graph. All right, let's see how we can potentially find the equation of the line. Equation of the line. So far we have found out that for this particular graph, our m is 1. Our m is 1. Now, let's try to come up with the equation. So, at the beginning, I think I mentioned that there's a formula that looks something like this. M x minus x1. Now, this is called, again, slope-intercept form. If you move the x minus x1 to the other side, it kind of looks like the slope formula, which it is the slope formula. But so far, we know our m is 1. Okay, anything else is kind of strange. We don't really know what they are, but we kind of do. But so let's see. I see that there's y and x without any number on them, and then there's y1 and x1. Now the reason for that is we're going to save this one and this one for the final result. What do I mean by that? So final result should be, or can be, in this shape, right? Now, in this y equal to mx plus b, we have y and x. So that's what I mean. We're going to reserve these for the end. So we're not going to substitute any number to them. We're just going to keep them as they are. So the question comes, then what is y1 and x1? Okay, usually students are confused here saying, okay, I have 2 points here. How do I decide which one is my y1 and which one is x1? So the answer is it doesn't matter. As long as a point is on the graph, it works. So you can take A, you can take B. Again, don't take x from one and y from the another one. As long as you take 2 points from one, 2 coordinates from one particular point, you should be fine. Okay, so let's take a look. All right, I'm going to take point A here. So 2 and 2. Okay, so let's plug it in. Y minus 2 equals to m is 1 times x minus 2. Okay, I'm going to do a bit of an algebra here. So 1 multiply x minus 2 is still x minus 2. Now let's keep y on one side and move numbers to the other side and x. So y is equal to x minus 2 plus 2. This plus 2 comes from here. Okay, and that's going to be equal to x. So what we just found out, the equation that we're dealing with here is y equal to x. Now, is that right? Yes, it is, because we just draw it here. Okay, so now these are a common type of questions when you're given a graph and you have to find the equation of a line, or part of the graph is missing, you're given a point or couple points, etc. Again, are we going to get the same result if we take point B? I claim that we will, but feel free to pause the video here and try it out. So as long as, like I mentioned, as long as the point is on the line, if the point is, okay, what does it mean to be on the line is, it means it follows the equation that you have. If the point, if I take a point here, for example, I don't know, 2, 3. Now 2, 3, you see it's not on the line, it's outside here, right? That means it doesn't follow the function that we have, y equal to x. It doesn't follow that rule, because function is basically a behavior, a rule, right? So it doesn't follow that, that's why it's outside, right? If I change it to 3, now it's going to be on the line, so it follows y equal to x. Okay, so as long as the point is on the line, then you can use that for your slope-intercept form. Now that we talked about what a slope is and how to find it, and we talked about slope-intercept form, I think we can try these questions. So let's start nice and easy. Find the slope of a line that passes through 1, 2, and 4, 5. So m, let's put 1, m is equal to y2 minus y1 x2 minus x1. All I have to do again, plug the values. So y2, 5 minus y1 is 2, 4 x1 and 1, sorry, 4 is x2 and 1 is x1. That's going to be 3 divided by 3, which is equal to 1. 2. What is the slope of a line through 2, 3, and 2, 8? It's the same question. So m is going to be, feel free to pause the video and try them out for yourself. Not only feel free, you should be doing that. Now this seems a bit strange. We got 5 divided by 0, which is undefined. We can't really have that. We can't really have this. So there is no slope. Now earlier we talked about a case where a slope is undefined. So what could be the case here if slope is undefined? Line, as you can see, both points are 2 and 8, and they get the same value. So this is basically a case of, I'm going to graph it here for you guys, and you will see how that is even possible. Actually, we did a similar question earlier, but in a different shape. So I've got y equal to 2. No, not y equal to 2, x equal to 2. That's what this equation is, x equal to 2. Now, at 2, it gets 3. At 2, it gets 8. So 2 stays the same, but y value changes. That means it's a vertical line which has an undefined slope. Number 3, the line the line through -1 and 4 and 3 and -2 has a slope. Okay, that's actually a question. It's basically the same question. M equals 2. You have to be careful with the negative numbers. I've seen a lot of students make mistake here, and which I just did. -2 minus 4, y2 minus y1, and 3 times -1. Yes, these can get confusing, and it could cost you marks for not because of difficulty, just for lack of attention, which I just experienced. So this is going to be -3 over 2 or -1.5. I hope I didn't make any calculation mistake. Let's double check. -2 is y2 and y1 is 4, so -2 minus 4 and 3 minus -1. Yes, that looks okay to me. A line has a slope, we're talking about question 4 now. A line has slope 2 and passes through 3, 7. Find its equation. Okay, we know the slope. M is 2. And we know what? And we know it passes through 3, 7. So we can use the slope-intercept form. Yes? Y minus y1 equal to mx times x1. So y1 is going to be our y value. X1 is going to be our x value. And m is 2. All we have to do, just do the algebra now. Y minus 7 equals to 2x minus 6. I just opened the bracket. So y is equal to 2x minus 6 plus 7. And that's 2x plus 1. So there you go. That's our equation. And the last one, it says hard, but let's see if it is. A line passes through point x2 and 5, 10. If the slope is 4, what is the value of x? Okay, that's an interesting one, because now the other stuff are given, sort of. Slope is given, 1 point is given, other point is partially given. So how can we tackle this question, actually, before I even solve it? Let's talk through this. Now, if I have just 1 point, which is 5, 10, and the slope, that's enough for me to find the equation of the line, which we just did in question 4. Okay, if I have the slope of the line and I know a point on that line, I can find the equation of the graph. Equation of the line. Yes? Now, how is that going to be useful for us? Because once I find the equation of the line, every point on that line should follow the same rule. We talked about that a bit earlier. So what I mean by that is, let's say I found out that this is my graph. This is my equation of line. Okay. If x2 is on this line, we don't know what x is. Let's say this is x2. That means whenever I plug in the value of 2 for y, I should be able to find x, or the other way around. Let me show you. I'm going to erase this one, just so I have a bit of space. Again, step 1, I'm going to find the equation of the line. So slope is 4, so y minus 10, y10, because y1 is 10, equals to 4x minus 5, open the brackets, 4x minus 20. So y is going to be equal to 4x minus 20 plus 10, and that's going to be 4x minus 10. So that's my equation of the line. Now, are we done? No, we're not. Now that we know our equation of the line, let me rewrite that here, 4x minus 10. Any point on this line should follow this rule. So we're given that we have x and 2. So whatever x is, when we plug it in, we get the value of 2. So what I can do, use the 2 and find x. Let's see at what value of x we will actually get 2 for y. So I keep 4x here, 10 to both sides, adding 10 to both sides, that's 12, and x is going to be 3 if I divide both sides by 4. There you go. So 3, 2, that's basically the answer. is on this line, same as 510. Now, is that the case? Did I do it right? I don't know. Let's see. So, my equation is y equal to 4x minus 10. Okay? Now, I'm going to mark my points. I need to turn on. So, my points are 3, 2. Yes? And 5, 10. Now, obviously, you're not going to do that in the exam. But just, we're still reviewing. If you have any gaps, this is the time to fill them out. So you see A is on the line and B is on the line. I didn't really label the second one B, but 3, 2, 5, 10. They're both on the line, so we are correct. The next thing we're going to look at, this is going to be, we're almost wrapping up this topic. The next thing we're going to look at is parallel, which is usually, could be the sign that people use. Parallel, and perpendicular lines. Okay, now how is that related to our conversation, you might ask, and that would be a very fair question. Let's see how. So, again, let's say I have an equation, y equal to 2x plus 3. Okay, in fact, I'm going to draw that here. There you go. Now, I want to know if there is any relationship. Well, I know there's a relationship. I just want to show you how we can see that. So, I want to know if I draw a parallel line to this graph, would they have anything in common? Now, turns out they do have something in common. Okay. In fact, let me try one here. Y equal to 2x, say, plus 1. There you go. Now, these lines are parallel, okay, which means they never cut each other. Yes, just zooming out. So these lines are parallel to each other. Now, I can sort of see that on the graph, which wouldn't be very accurate because they might go in a very narrow angle, so we don't really notice if they are actually cutting each other or not. But the good indication of a parallel lines is, let me write that here, y1, y2, 2x plus 1. The good indication is having the same slope. Same slope. So if somebody comes up to you in the streets, which is rare, and they ask you, I have an equation. I'm just going to put a side note here. Let's say they give you equation y equal to 85x minus 42. And they tell you, can you give me an equation of a line that's parallel to each other? Now, the 85 can scare you, and you might say, I don't really have the tools with me right now. Let me just, call somebody up, run home, and get my stuff. You could do that, okay? But the easiest thing is to do is just come up with another equation that has 85x. So you don't touch this part, and just add, minus, subtract, whatever you do with the rest. So the interception part doesn't really matter because all it does is shifting it up and down. It doesn't tilt it because tilting is the job of the slope. It just moves it up and down. Oh, sorry, I just touched the microphone. It just moves it up and down. So very easy to create a parallel lines. You just have to come up with another equation that has the same slope. That's all there is. A same slope. Again, what is a slope? Slope is, in the equation of y equal to mx plus b, slope is the value that stands in front of x. So it's the coefficient of x. So that's a parallel line. What do they have? Same slope. Now, how does that come up in the exam? Excuse me. How does that come up in the exam? They usually give you an equation. And then they say, okay, there's a parallel line to this equation. Find the y-intercept of that equation, the other equation that's parallel to it. So as long as they give you parallel or perpendicular, these should be triggers. These should be triggers that you should remember that in parallel lines, m1 is equal to m2, m being the slope. So if two lines are parallel, immediately you think of m1 equal to m2. Now, what's the relationship in perpendicular lines? The relationship here is a bit strange. It's equal to negative reciprocal. So 1 equal to m1 equal to negative 1 over m2. Okay, again, I'm not going to graph it just yet, but I'm going to try to come up with an equation. So let's say y1 here. Let's look at this one. Y1 is my line, and I want to come up with an equation that is perpendicular to it. So all I have to do is find my m2. Okay, let's say, let me erase this so we are nice and clean. All right, so I need to first find my m2. So I see my m1 is 2, equal to negative 1 over m2. To use my algebra magic, m2 is going to be equal to negative 1 over 2. Okay, again, same as we did in the parallel lines. It doesn't really matter what type of y-intercept you have. All you have to make sure is the coefficient of x, which is the slope. So y2 is going to be equal to negative 1 over 2, x plus whatever, 18. Yes? Let's actually try it out. Y equals to negative 1 over 2 x plus 18. No. X plus 18. Where is it? Did I make a mistake? There it is. So these lines are now perpendicular to each other. And there it is. Okay, so that's going to be what we need to remember about parallel and perpendicular lines. Usually students have a lot of problems when it comes to parallel and perpendicular type of questions. So what we need to remember here is two things, right? If the lines are parallel to each other, that means m1 is equal to m2. And if they're perpendicular to each other, then m1 is a negative reciprocal. Yes? That's all we need to remember, and everything else will take care of itself. Let's take a look. Question 1. Find the equation of a line parallel to y equal to 2x plus 1, passing through 0 and 4. Now, let's break this question down. We have an equation 2x plus 1. They want another equation from us, which is parallel to this one, but not any parallel line, because we can create infinitely many, but the one that passes through 0 and 4. Okay, now if you remember, we said if we want a line that's parallel to the line that we're given, all we have to do is just match the slope, which I did. Now I could put 3 here, 5 here, whatever, doesn't matter, but now it does, because they're asking us that it has to go through 0 and 4. So I'm going to leave this as a variable because we don't know. We need to find it out. Now, how can I find out? Did they help me? Did they try to help me with that? Yes, they did. They gave us a point, is 0 and 4. So if I plug in 0 for x and y for 4 for y, I should have my answer. So 4 equal to 2 times 0 plus b. 2 times 0 is 0, so b is 4. Now, are they asking for b? No, they're asking for the equation of a line that's parallel to the given one and passes through. So we just found out y equal to 2x plus 4 is, no, not b. 4 is actually that line. Okay? 2. Find equation of a line perpendicular to this line and passes through 2 and 1. Now, all we have to remember again, these two rules. Okay? Now, I'm looking at this equation, y equal to 1 over 2x plus 3. and I see the slope, let's call it m1, is equal to negative 1 over 2. Now, if they're perpendicular to each other, the other one is going to be negative reciprocal, which means it's going to be negative 1 over 2. So, hopefully that doesn't scare you. That's equal to 2. Okay? That's not enough. We also need to make sure it passes through 2 and 1. So we're going to do what we did in the first equation. So y equal to 2x plus b is our equation. Okay? And all I have to do is plug in 2 for x, 1 for y. So 1 equal to 2 times 2 plus b, and b is going to be negative 3. So this one is a bit tricky. So let me actually check if that's the case. Y equal to negative 1 over 2 x plus 3. That's 1. And the perpendicular one we found is y equal to 2x minus 3. There you go. It seems all right to me. Now, I can't 100% say that they're perpendicular just by looking at the graph, obviously, unless I have a thing to measure the degree. But they seem perpendicular to me, and we followed the rules, so we should be fine. All right, let's continue with question 3. Line A, y equal to, let me put 3 here, y equal to 3x minus 2. Line B passes through 1, 4, and it's parallel to line A. Line B passes through 1, 4, and is parallel to line A. Find line B. So if they're parallel, again, they should have the same slope. So let's call this one y1 for A. This is y2 for B. They have same slope, but we don't know the y-intercept. Again, how we can find that out? Because we have a point 1, 4. We can use that. So I'm going to plug 4 for y, and 1 for x. 3 times 1. Plus b, and 4 minus 3 is going to be 1, so b is equal to 1. So I just found out my equation for the second line, which is b, is 3x plus 1. Is that what we needed? Find line b. Yes, I guess that's what we needed. Good. We can move on. Question 4. Question 4 says, write the equation of the line perpendicular to 2x plus y equal to 5 that passes through 4, 1. Again, rinse and repeat, same stuff. 2x plus y equal to 5. Now, if that looks confusing to you for some reason, you can rearrange it so it looks like y equal to mx plus b. So, negative 2x plus 5. So, our slope is negative 2. And m2, since these are perpendicular, it has to be negative reciprocal, which means negative 1 over negative 2, and that's just positive 1 over 2. So that's going to be my slope for a line that's perpendicular to 2x plus y equal to 5. But I'm not done. It has to go through 4 and 1. Again, I have y equal to 1 over 2x plus b. I don't know what b is yet, but I'm going to use the point 4 and 1 to find out. So 1 for y and 4 for x plus b. Again, 1 minus, these will cancel out. There's 2. 1 minus 2 equals to b, and then b is going to be equal to negative 1. So my equation for the second line is going to be y equal to 1 over 2x minus 1. All right, the last thing we're going to talk about in this topic is going to be simultaneous linear equations. Now, what are simultaneous linear equations? Simultaneous linear equations are something like this. X plus y equal to 5, right? And let's say, I'm trying to come up with it. I really should have had example before that, actually. So let's say 2x plus 3y, 2x plus 3y equals to 13. I think this should have a solution. Okay, so how is this stuff related to what we talked about? Now, the reason it's related because simultaneous equations, well, in this case, it's simultaneous linear equations. So if we look at them independently, they are just lines. But how we can use our knowledge to solve it. Now, you can look at them as simultaneous equation and solve them with addition, substitution rule, which we can. Maybe we can do that here, actually. So I see that there's 2x here and x here. Maybe I can multiply the first equation by 2, right? Just bear with me here. So 2x plus 2y equal to 10. The other equation is 2x plus 3y equal to 13. Okay, now I can take the second equation, let's call this E2, and do E minus E1. Why would I do that? Because that will get rid of my x. So x will disappear. I will have 3y minus 2y equals to 3. So y is going to be equal to 3. If y is 3, I can plug that in back to the first equation and find out that x is going to be 2. That's one way to solve it. But how we can use the graph? Let's see. I'm going to turn these ones off. Come on. Doesn't allow me for some reason. Okay. Let's see. X plus y equal to 5. There you go. That's line 1. And the other one is 2x plus 3y equals to 13. There you go. Now we see that these two lines are intersecting. Where? At point 2 and 3. Now how easy was that? We just found the solution to this equation without solving them by using decimals. So here comes the caveat to this. As it turns out, the solution to a simultaneous equation, while we do it, algebraically, substitution, addition, what I just did, what essentially it means the intersection point. The intersection point. Right? So if we have two equations, simultaneous equations, we're trying to solve them, and what we're really trying to find out at what point they are cutting each other. And if they do, that's going to be our answer. They don't always do, obviously. Why? Because we can have parallel lines, right? If we can solve a parallel line, you will see the simultaneous equation is trying to act up a little. For example, 2x plus, y equal to 5, and 2x plus y equal to 3. Now, how do I know these lines are parallel? If you listened carefully earlier, you would have noticed if the m's are the same, the slopes are the same, then these lines are parallel. The numbers, the other stuff don't matter. Okay? Now, if I try to solve it, you see if I try to do like a subtraction here, then x and y will both disappear. So I will end up with, if I do first equation minus the second one, I will get 0 for x, 0 for y, equal to 2. So this is very strange, as you can see, unless you're not like some math philosopher. 0 plus 0 is not equal to 2. Okay, how, again, let's see that in a graph. So 2x plus y equal to 5. 2x plus y equal to 3. So let me turn these ones off so we can see. There you go. We have parallel lines and they're not cutting each other. So this has no solution. This has no solution. Okay, so again, to wrap up, how is linear equation and simultaneous? Well, actually not how they're related, because that part is obvious. What does simultaneous equation actually do is try to help us to find where these two lines are intersecting. And usually you will see the questions, actually in SAT maybe it could be a bit different, because usually there's questions about when there is no solution and when they're parallel to each other, etc., etc. But the idea, the essence behind a simultaneous equation is to find out where, if and where these two lines are intersecting. All right, lastly, we're going to look at how to solve simultaneous equation. We talked about some theory behind it. Now, we can solve simultaneous question by hand, but again, that's not the purpose. That's not the purpose. We're going to use our graph Desmos skills to find out. So first one says solve y equal to 2x plus 1 and y equal to negative x plus 4. Again, we can use the traditional on-paper methods, but we don't get extra points for that. So I'm just going to type it here, 2x plus 1. And the other one is y equal to negative x plus 4. So, and all I'm looking for is the intersection point. Hope you remember that from the theory part. It looks like 1, 3 is their intersection point. How easy was that? It was about 15 seconds. So 1 is going to be 1 and 3. Question 2, same stuff, solve. Let's try it, why not? I had the temptation of not doing it, but 2x plus y, no, sorry. 2x plus y equals to 7. You don't even need to rearrange it so it looks like y equal to mx plus b. What happened here? Okay, this minus. And x minus y equal to 1. Okay, let's zoom out. Yes, they do intersect. Let's click here to see what point that is. That looks strange, but we'll take it. 2.6 and 1.66. So 2.7 and let's make it 1.7. There you go. Easy. System of equation 3x plus 2y, x plus y equal to 5. Again, you put it to Desmos and you see if you have any intersection points. I'm going to actually give in to the temptation of not doing the same question again. Fourth one, a bit wordy. Let's see what that says. A school sells 40 tickets. Adult tickets cost $5. Student tickets cost $3. Total revenue is $160. Find how many of each ticket were sold. Now, this is a common question type where we have to kind of construct a simultaneous equation. So, let's break it down. What do we have here? We have different types of tickets. Let's call them X and Y because, you know, we're used to X and Y. X is, let's say, adult ticket, and Y is a student ticket. So, adult ticket costs $5, student tickets cost $3. Total revenue is $160, and school sells 40 tickets. So, the amount of tickets sold is 40, so X plus Y should be equal to 40. And total revenue is, for example, if you're selling I don't know, 3 tickets. This is going to be 3 times 5. Why 5? Because the cost is 5. So we're going to make it into an equation. So 5x plus 3y, why 3y? Because student ticket is $3, is going to be equal to $160. That's all. We're back to square one again. You can put it into the decimals and see for yourself if there is a solution to this one. Last one, solve for intersection. Again, we can do it by hand, but we're not going to. So I'm going to actually do this one because this is the last one. And then we'll be done. Y equal to 3 over 2 x plus 1. It's the fact that I can't just copy paste annoys me because it's a screenshot. There you go. Let's see if they do even intersect. Sometimes when you use decimals, I've seen students, they look at this like a minimized or zoomed in version of the graph and they're like, okay, I don't see the other graph. Sometimes you might need to zoom out quite a bit actually. This one is not that far because it's at, where is it at? 3.27 and 5.9. But sometimes the number can be like 100 something and then you have to really zoom out to see what, if and where they intersect. 5.9. There you go. There goes your simultaneous equations with decimals. All right, guys, I hope you enjoyed that session and I hope you really learned something. If you have any suggestions, please feel free to mention them. I'm really looking forward to hear your comments and I hope that these exam series and these review sessions rather would be very helpful and hopefully it will give you extra points in your September SAT exam. With that being said, thank you for tuning in. Make sure if you find it useful, subscribe, share with a friend if you think it might be beneficial for them. All right, see you tomorrow with day 14.